Okay, so let's get started. Hope everybody had a good lunch or some snacks. My name is Lukáš, Krejčí, I work for Red Hat, and today I want to talk to you about evolving APIs in Java, or rather, problems you may run into. There are, books by quite more clever people than I am that talk about how to do it. I'm just show you the problems you will run into if you've not read the books. So, stuff evolves, as we all know. I was shocked to see that there's almost 1 million different versions of different libraries in Maven Central only. So, what's an API? If you evolve, what can change? What user might be affected by? Obviously, your code changes. So, if the users used your library in version 1 and want to upgrade to version 2, they obviously will face the changes you have made. And also, you will use some configuration schemas or whatever kind of schemas you might have in your code base. And those will change. And if people use it, stuff will break for them if you change them incompatibly. And also default configuration, because, if they assume that your library behaves in some way and you change that way, the default way, they might be surprised. And, users don't like surprises. That's the whole point of this talk, I guess. In Java, the situation is quite bad because there is no concept of versioning at all in Java language. The unit of encapsulation is package, and you can shove package in different jars. Nothing checks for the fact. And we're all waiting for Java 9 to bring us modules, and I'm not completely up to date about how it will look like, but I hope we'll get some sane Maven-like versioning of modules. So A is a program, L is a library, you're the author of the library, and a user uses your library. And you want to have a relationship between each other. You want users to use your library and give you or report bugs and request features and all that, so that your library is alive. And users want to use your stuff, but they don't want to change their code. They don't want to have additional work because of the changes you've made. I'm playing Captain Obvious here right now, but it's going to get more interesting, I hope. Also, if you're a user and you have an application running in a container, like your web app running in Wildfire or wherever, you want to update the container sometimes. There's a security fix you want to apply, and you don't want your application to break because of that. So the container writers need to make sure that change doesn't break user applications, and that's quite hard to do because there are at least 3 kinds of compatibility. Source compatibility with code is, obvious. If you compile with version 1, you should be able to compile with version 2. Binary compatibility, the linker needs to link the stuff together so that it can run together. And behavior compatibility, that's the hardest part. I think there's no automation possible for that apart from unit tests, and those are not perfect, so there will always be behavioral incompatibilities, I guess. So here are some short examples of what source compatibility looks like in Java code. You can add a method to final class that cannot break user code. If version 1 of the library doesn't have that method and version 2 does that have method, nothing could have called that method before or could have relied on it. So that's completely safe. not okay changes, if you change the number of parameters in a method, in a public method that can be used, obviously when user upgrades, they will need to change their code. Binary compatibility, is somewhat similar, but the rules are different because the linker rules are defined in Java language specification. And for example, if in version 2 you throw a new exception out of a method, and you can even declare it, throws, I don't know, illegal argument exception, that's a compatible change when it comes to the linker. Obviously, if you change the method from instance to static, that is a no-no. Even though it might be source compatible, it's not binary compatible because JVM actually uses different bytecode to call those methods. Behavior compatibility, as I said, you have to have a test suite, a TCK of sorts, that will check that your library behaves the same or as it should. And if there's a bug and in your code and your users worked around it in some way, and then in version 2 you fix that bug, their workaround no longer works and might cause problems to them. So behavioral compatibility is kind of strange. There's no obvious way of solving it or keeping it. So now to the slightly more interesting part of the presentation. I've come across this Java library evolution puzzlers, which is A, survey, B, a talk, and C, a code repository made by Professor Jens Dietrich. I think he's German, but he lives in New Zealand. And I took the survey, and I was surprised how wrong I was in my experience with Java. I thought I knew what I could do, but I apparently didn't. So let's just take a short quiz here. I'm going to show you 7 little programs and libraries, and we will see library in version 1, library in version 2, and a user program that was written against version 1 and wants to run against version 2 also. And we will then, check if it all runs and fits together. If you compile the program with version 1 and run with version 1, it should work. But what if you, compile against version 1 and run with version 2 of the library? That can happen, for example, in the container scenarios. You update, you have your application, it's deployed somewhere, and the container you're running your application in gets an upgrade. And suddenly there can be a new version of the library that you consume from within the container. And then the final test will be if the program that was written against version 1 compiles with version 2 and runs with it. So first, that's kind of easy, adding an interface to a method. So in version 1, we have an interface that only has one method, foo. In version 2 of the library, we add a new method called bar. And our program implements this interface. So, and then, tries to instantiate and call the method in its main. So what do you think? It will compile and run with version 1. That's kind of obvious. Will it compile with version 2? No. And if you compile the program with version 1 and run it with version 2, will it run? Will it work? Yeah. Okay. So yeah, you were right. And that's because adding a method to an interface is a binary compatible change, because nothing in the program could have called that method. Constants. We change, there's a constant of primitive type. In one version of the library, it has one value. In the later version, the value is changed. We want to print that value. So compilation is fine. There's no problem in there. What's the interesting part is the output. So in version 1, we have 42. In version 2, we have 43. What will be the output? I'm particularly interested in the middle column. What do you guess? 42. Of course. And that's because? Yeah, constants are inlined during compilation.
Not all constants, just the primitive types.
All right, we'll get to that. Yeah. The constant must be a constant expression. Is the precise term. So if there was.
If it was an integer instead of int, it wouldn't be inline.
Yes, yeah. And also if you didn't initialize that value right here using equals, but had a static code piece, that would not be inline either. So yeah, coming to your example. But do you know what will happen in here? String is a reference type. Will it be inlined or not?
Well, no.
No, yes, no. So we have both answers. It will be inlined. That's, because strings are special. So no, but they have a special treatment in the compiler. So strings are inlined. So again, we will have 42. So if you ever see a public static final string called version, and the library author thought that you would be able to check that field for the version of the library, they were wrong, right? Because you won't. Unless you recompile, of course. So in here, we are adding a checked exception to the method. In the later version of the library. And we want to call that method. So again, what's it going to look like? In version 1, that's going to work. We've written it that way. If you compile with version 2 and try to run it with version 2, that's going to break because you don't catch that exception. And it's a checked exception, so the compiler will complain. But will it run when you compile against version 1 and run it with version 2? It's throwing a checked exception, yes. Will it run? Yeah, it will. Because actually the exceptions are not part of the method descriptor that the linker checks when it checks for compatible method calls and stuff like that, when it links stuff together. So the exception is actually thrown from that method, and it will bubble up all the way and exit your program, which is completely unexpected because it shouldn't have.
There is also a way to convert a checked exception using generics to convert a checked exception into an unchecked method call. So there is a way, completely generic in Java. Since Java 5, there is a way how to throw up a checked exception.
Uh-huh. Right. Yeah. Because
It's very tricky, but it has to be done using generics.
Mm-hmm.
It can be done.
So you basically you throw a type parameter, if I understand correctly.
You have to encapsulate the method that returns a reference to, well, I don't recall it exactly at the moment, but there is a way how to do it.
So again, this is possibly complex, and changing return types in a covariant way. So, version 1 returns a collection, version 2 returns a list because you realized, collection is unnecessarily generic. That is, I would say, a safe change because, user code cannot break because, list is a subclass of collection, so there cannot be a problem at all under any circumstance. So what's it going to look like? Version 1 will work, version 2 will work, compile and run correctly. What about if you compile with version 1 and run with version 2? Will it work? It should, right? Yeah, there's going to be a linkage error because the linker does not know the relationships between types and the types are different, so it will just throw up. So yeah, no such method error. Quite a popular one if you look at Stack Overflow. Yeah, type parameters, my favorite. So you change the type parameter from string to integer, completely unrelated types. And you try to use these using the same program. So version 1 will work, version 2 will fail to compile. The middle column, how is it going to look like? It will work. Yeah, it actually depends. It will work until you rely on that type parameter having a certain type. So yeah, the output will look like this. So that's just a short quiz. There's many more questions to be answered when it comes to API compatibility, and I'm not going to, we could be here for a long, long time. So the question is, are there any tools to help you with API evolution? And turns out there are. And SIGTest is first one of them. It comes from Oracle. It's actually used, I think, in TCK for checking that Java APIs remain binary compatible and are completely, safe to upgrade. It also has an evolutionary mode, so it can, tell you what were the changes between versions and if they are safe or not. But this guy is not in any public repository where you could easily include it in your build, specifically Maven, because I like Maven. So you have to download the library from their site and use it, using command line, or even though it has the Maven plugin is not accessible from anywhere, so you have to download it manually anyway. And the Maven plugin is kind of limited because you cannot use it in a way that I think is actually useful for developers. If you write a library, you want to check during build that the changes you've introduced since the last release aren't breaking the library API. And that's not possible using the Maven plugin, so you're kind of stuck with Ant or whatever horrible other tools. On the other hand, it supports Java 8. So all the new features like default methods and type annotations, all are supported. Another one is Clear. I think that's, for some strange reason, the more popular one. It's actually quite nice. I've used it for a couple of years. I even contributed changes to its Maven plugin. But the thing is that Clear library itself is basically dead. Its last release in 2009 and doesn't support any Java 5 features, which actually does not matter that much because the bytecode is quite, still very similar between Java 4 and Java 8. But you cannot check certain things. So, and for you as a library author, it is quite nice. because the Maven plugin can be told to ignore certain changes. So, for example, if clear thinks there's a breakage, you can assess it and say, well, this is really necessary. I don't care if I break the API because I need to do it. And for the Maven plugin to not fail your build because of that change that you want, you can tell it to ignore the change. Basically say, I want this, don't break my build. But at the same time, it will warn you that you made that change and the decision you made is conscious, as opposed to just randomly change stuff. And there's Java API compliance checker, written in Perl, horrible, one huge Perl script that only outputs HTML as far as I know. So don't use this, even though the reports are quite nice, to be fair. But only HTML, so no automation possible. And then, of course, there's Revapi, which is a new thing that I decided to start when I got fed up with all of the above. And the reason why I started is mostly usability. I just don't want to spend too much time looking at reports and thinking. Basically, I want to Maven install or Maven verify and be told. So, and of course, at the start we said that API is not just code. So I want to build it in a way that it's language agnostic, basically. It just checks 2 trees in parallel and looks for changes. And by incidence, there's a Java extension to it that checks Java code. There's over 30 breaking conditions that it can change. It's on par with the rest, basically, but when it comes to checking Java API. Although there are bugs, obviously, it's just version 02. Yep.
Is it comparing on bytecode level?
Yes. Bytecode. It's got Maven integration that I think makes sense a little bit because you can, because it's extendable. You can have different things checking for different aspects of the API. So if you want to check Java code, you just depend on a Java extension. You can configure it, and it's got build time checks that can fail your build, and it's got even a simpler report. The configuration is JSON. In here, we say just don't even look at my impl classes because they are not supposed to be. They are not part of the API. By me saying it, Java has no way of enforcing that, but I'm just saying this is implementation. Don't check that, and I'm actually ignoring all the problems you find with Java fields for one reason or another. You can just say that this is just an example. You can say that you can have one file that basically tracks your API evolution across versions. So in version 101, I've made these changes and these are ignored because I've made them and I want them there. You can continue in that file like that. And you can configure this to look this kind of reporting using that Maven configuration. And this is what it will tell you when you make an incompatible change. This is one of the quiz examples. We've changed from collection to list, and this is what we would get if you build that with Revapi turned on. It would say to you, cannot do that. This is a binary breaking change. This is how the Maven report looks like. And it's got a standalone mode too, so I just tried it with an old version of JBoss modules to see if there are any changes in this. The API of JBoss modules is relatively small and simple, but you can see that even though there are basically breaking changes in every other library there is, and JBoss modules is a prime example of very nice library that is, very well written and extremely cool. But even that can break. I'm not saying that these changes are important. Maybe most probably they aren't, but still there's been nothing that would have told you that you're making a change. Please judge if that's okay or not. So that's mostly it. Here are links to the various tools. I especially encourage you to look at the last one. And that's it. Don't be evil. Don't break user space, as Linus Torvalds told in one of his famous rants. Yep.
So the main use case is for an API maintainer, and it's not for API consumer.
I guess, yeah. This is for mainly for the question was whether this is for library authors or library consumers. I would say it's mainly for library authors to check that when they evolve their code, they behave nicely to their users. But it can be used by users too, to see if I want to upgrade to a new version of the library. Is it safe or not? This will just do static analysis, so it will tell you the potential problems. It won't help you with the behavior compatibility, of course, but yeah. Yep.
And does it work with other languages on JVM?
Question is, does it work with other languages than on JVM, for example, Scala? Well, it works on the bytecode level, so it will kind of be able to analyze it. The question is whether it will make sense in the context of that language. Because Scala does very weird tricks on bytecode level, and you cannot know if a construct in certain that has been translated into bytecode will transfer, or whether two constructs, different constructs on bytecode level are compatible within context of Scala. So it will kind of work, but it probably won't make sense. There would have to be another extension that would make sense of those differences. Yep.
Have you thought about incorporating this into package provider servers? Like the servers that provide packages with libraries, right? So that automatically I could check through the web interface, so the RPM.
Right. That could be done. Yeah, that could be done. For example, in here, this is the command line tool, and you just say to it, compare these two versions of the libraries. You just give it Maven coordinates for those libraries, and it will download all the stuff, and including dependencies and check for changes. So a web service of sorts could be easily done using this. Yeah. Yep.
It really sounds very relevant to things like semantic versioning.
Yes.
Would it be able to output what kind of version?
Question was, this relates to semantic versioning. Would it be able to compute a new version? Yeah, that's on the list. It should be fairly easy because if there are changes but all are compatible, non-breaking, then you only increase the micro version in a semver type of versioning. If there are new features but no breaking changes, you can add new minor version. If there are breaking changes, you increase major version. So yeah, that's in the pipeline, and it shouldn't be that hard to do. So like extending Maven release plugin using this. Any more questions? Yep. Yes, I'm using ASM. The question is what kind of library do I use for bytecode analysis? ASM. And also, well, that's kind of internal, but I first analyze it using ASM to figure out the API, and then I actually compile the libraries with some dummy code so that the extensions that can exist can consume the same API as annotation processing. So you can, have annotation processors can, scan for code and can, analyze it using a Java API that exists for it. So I'm trying to use or expose the same API, not invent my own. So I first analyze it using ASM and then compile it and and let the checks run with the JavaX model API. Any more questions? Okay, so that's all. And if you please leave feedback on this URL. Thank you. Děkuji. Čaj. Kurňa, taky jsem to dělal včera do 3 do rána, kurňa.
Na Kubernetes teďka?
Na koho?
Na Kubernetes, tam je workshop.
No jo, to bych mohl, no. A pak už musím jít domů zas.
Jsem byl včera právě, no.
Tak. No, opakovat otázky, to je peklo, člověče.